Chapter 17, Problem 9. At 25 degrees Celsius, the vapor pressures of pure toluene and pure benzene are 28 torr and 95 torr, respectively. Part A. What is the vapor pressure of a solution prepared by mixing 40 grams of toluene with 15 grams of benzene at 25 degrees Celsius? So we know that mixing the two together will affect each other's vapor pressure. So the vapor pressure of pure toluene versus the solution and the vapor pressure of pure benzene and the solution are totally different. So if we want to find the vapor pressure of a solution, it's the sum of all the individual vapor pressures. We could find the individual vapor pressures by using Raoult's law, which means we're going to have to find the mole fraction. So let's find the moles of each. So to get the moles of toluene, we have 40 grams. The molar mass is 92.15. So there is 0.434 moles of toluene. For benzene, we have 15 grams. Molar mass 78.12. So that gives us 0.192 moles. The total moles ends up being 0.626. Okay, so the pressure of the toluene is going to be its mole fraction, so 0.434 out of 0.626. And then his P naught was given to be 28 torr. When we multiply that through, we get 19.4 torr for toluene. For benzene, same thing. We have 0.192 out of 0.626, but his pure vapor pressure was given to be 95 torr. So his new vapor pressure will be 29.1 torr. And so the pressure of the solution is the total, 48.5 torr. Part B. What is the mole fraction of the benzene in the vapor above the solution? So if we're looking at the flask, down here in the solution, there was 0.434 moles of toluene and 0.192 moles of benzene. So the mole fractions in the solution we used to get those vapor pressures. But then up here in the gas phase, the moles of the toluene, we don't know. And the moles of the benzene, we don't know. So how would we get the mole fraction of the toluene if it's in the gas phase if we don't know those moles? Because mole fraction is going to be the moles of the toluene over the total moles. Well, we don't know any of those, but we do know that it's a gas. So because it's a gas, moles is PV over RT. So if I substitute this into here and into here, what you end up getting is mole fraction of toluene is the pressure of the toluene times the volume over RT, all over the total times the volume over RT. Well, the volume is the same, R is the same, T is the same. So the mole fraction of the toluene is just the pressure of the toluene over the total pressure. Now we actually learned this in Chem 1A. This is called Dalton's law. So the mole fraction of the toluene, the pressure of the toluene we saw was, and this is part A, 19.4. Whoa, 19, not 12. And the total was 48.5. So that gives us a mole fraction of 0.4. For benzene, his pressure was 29.1. Again, that's from part A, total 48.5. And this comes out to be 0.6. And it makes sense because the sum has to be 1 for fractions. Okay, now keep in mind that we can only use pressure for the gas. We can't use pressure for the solution. If I came down here and I wanted to figure out the mole fraction of the toluene, it's going to be 0.434 out of the total moles, which is 0.626. And this does not equal 0.4, like we got over here. So the gas fraction and the solution fraction are not going to be the same. I mean, it's probably possible that they could be the same, but it's very unlikely that they're going to be the same.